Hi, so I wanted to take some time to go over this thing that I talked about, or I mentioned it on the Facebook group at least, the Committee on Best Practices in Data Analysis, or the COBIDAS report. Another way of thinking this is just simply they're creating a document that is supposed to be something that people can use to follow in order to just do good science. And they don't want it to be like, we're in charge, this is what we say you must do. Instead, they're trying to create a document that was created interactively. So you can either use this to just learn about the steps that are in the document, or if you're interested in giving feedback, this is to fuel that as well. So what is COBIDAS? It's an OHBM committee that was formed in 2014. It stands for Committee of Best Practices in Data Analysis and Sharing. Yeah, I don't know what happened to the P either. The goals are to identify best practices of data analysis and sharing in the community, prepare a white paper, seek input from the community, and publish recommendations. And currently, they're at this stage of seeking input from the community. When is the input due? Well, the input's due by November 17th of 2015. So if you're watching this later, you can probably just find the final report. Well, I'm sure it'll take a little bit after November to compile the final report, but that should be available soon. And you can use that as basically a guideline for your lab to follow, or for yourself personally to follow when analyzing your data and collecting your data. So the link to this webpage is in the description box, and you'll see that you can both access the report and the tables. I'm going to go through the table briefly. That will be the presentation, just so you can see it. And then in terms of giving feedback, they've set up this WordPress account, and they've broken it down into the 7 categories that both the final report and the report tables are broken down into. So it's an easy way to give feedback. And you can interact with other people in the community, discuss different ideas. So why is this such a big deal? We have a bit of a reproducibility problem, both in just across the board, across a lot of fields, but there's been a lot of attention within psychological studies recently, and this definitely applies to neuroimaging studies as well, because we have so much data, there are so many ways to analyze the data, and there's so much room for error. Also, there's a focus in this report on data sharing, and we're a little bit behind other fields in terms of sharing our data, partially due to the complexity of our data, but better resources are becoming available. It's nice to share. We tend to be more clear about what we did if we were planning on sharing our data. And yeah, data sharing, I think it's great. I love it. So there are different approaches you could take to kind of fixing mistakes. One is self-correction, so you rely on reviewers to catch mistakes, or just as time goes, somebody else catches your mistake. So that's one end of the spectrum. The other end is that you register your research hypotheses before a study. So it's a very rigorous control. I'm going to study these things, and then you study those things, and then anything additionally you did is fine, but then people know it was exploratory. I actually know of labs that do this within lab. Sometimes I wonder if it's to shut me up because if they show me an ROI analysis, I'm always going to ask, where did you get this region of interest? And if they say, oh, I wrote it down before I even collected the data, here, look here, then, they shut me up. And I'm happy and they're happy, we're all happy. So anyway, yeah, I like this idea. I realize it's rigorous, and this is probably not rigorous enough. So this is somewhere in the middle, and it's this idea of being transparent. So share your data, share your methods, share your results. Again, these lists are not meant to be absolute rules, although you should, if you do deviate from these rules, you should have an explanation available for why you did so. So here are the 7 areas: experimental design reporting, image acquisition reporting, pre-processing reporting, statistical modeling, results reporting, data sharing, and reproducibility. Their definition of reproducibility is, I give you my data, my paper, can you reproduce my results? And I love this idea that they wrote in the white paper. We ask the authors challenge themselves, if I gave my paper to a colleague, would the text and supplementary materials be sufficient to allow them to prepare the same stimuli, acquire data with the same properties, pre-process in a similar manner, and produce the same models and types of inferences as in my study. I think it's a great idea, and if you think this is really out there, I've actually worked on studies where this is the case. It wasn't in neuroimaging, it was in pulmonary science, and it was a huge multi-center study, and I was not made aware of this when we were writing the paper, but before we submitted it, the PI was like, oh, well, we first have to let our paper go through, the sort of our internal review system. And somebody recreated all the analyses based strictly on what we said in the paper. I think it's a wonderful idea. Okay, so what I'm going to do now is I'm going to quickly go through this. This is the appendix that was given. It's the table. It is 21 pages long, so I'm just going to quickly go through it. I want you to see it. I'm going to try not to just read it word for word. We'll see. Just because I want you to both know these things so that you can implement them. Or if you don't like something, or if something's missing, you can comment about it. You could comment, and by the way, if you put any comments on this video or on the Facebook page or on Twitter directed at me or on the Tumblr, I will turn in your comments personally, anonymized. I'll just say that they were taken from whatever. Unless you want me to include your name, then I will. But you can also go directly to the WordPress blog, which is linked in the description box. Okay, so we're starting with the first of those. Remember I said there were 7 things. Experimental design reporting. Okay, so we have aspects, some notes about the aspect, whether or not it's mandatory. So you can see a lot of these aren't considered mandatory. So subject's approach, consented, who refused, subjects who are excluded. This is after consenting, but before data acquisition. So all these are not mandatory, but if you had a subject participate and they were analyzed, then you need to talk about how many subjects there were. And at that point, if they are excluded, why? You want to give descriptive statistics of age and gender. No matter what, you want to do that. Race, ethnicity, SES, and IQ, those are not required. Handedness, that's an important one for imaging data. Different exclusion criteria used, clinical criteria used, matching strategies, if applicable, if you did matching. Population and recruitment strategy, that's important. I've even noted, I know less about this than a lot of you probably do, but I'm always surprised, like if you use Craigslist versus something else, how different the populations are within the same city. Subject scanning order, so this is important. If you have to update your scanner midway through your study, it's not going to be good if all of your controls were collected before the update and all of your patients were collected after the update, because you have a built-in confound that you can't adjust out. So you want to kind of randomly order when the subjects were collected. Neurocognitive measures that were collected, you should describe and report those. Ethical considerations, ethical approval. You want to, here we use the Institutional Review Board or the IRB. Whatever your ethics committee is that approves it, you want to make sure they've approved it. Just to relate this, we're going to talk about data sharing later, especially if you're planning on sharing your data, you want to make sure that's approved before you start the study. Informed consent, hopefully you consented your subjects. Design specification, your design type. Be really specific. Was it event related or block design? The terminology is defined better in the paper. Your conditions and your stimuli. If you can have pictures of them, that's always really helpful. The number of blocks, trials, or experimental units, that's really important. I'm trying to recreate a study that was reported in a shorter paper, but for the life of me, I can't. I've had to email or had somebody email the authors of the paper multiple times because they didn't report how many unique stimuli they had and how often they were repeated, how many were in each block. They just reported the numbers of blocks and kind of a rough estimate of how many were in each block, which is not enough information for me to replicate their study. The length of the experiment, how long was the scanning session, how long was a run, whether or not you optimized your study. So we just talked about that here quite a bit. Did you use OpSeek? Did you write your own code? Were you optimizing detection or estimation, and what software did you use to present your stimuli. So all these things are necessary if someone wants to replicate all of this whole table, if somebody wants to replicate. Task specification, condition that was used, using shorthand name, that's kind of what I already said. Instructions, that's really important. What instructions were the subjects given? So this is especially important for resting state analyses. Was it eyes open, eyes closed? Did they see a fixation cross? Were they given rewards during the task? All that stuff. The stimuli, the specifics of the stimuli, and this refers to what I was just talking about, the unique number of stimuli that were used, whether and how they were repeated over trials and conditions. So if you randomly ordered them, if you randomly ordered them with certain restrictions, like the number of the same type of stimuli, it could occur in a row. Behavioral performance, variables recorded, and your summary statistics. So all of these things are required. It just seems reasonable. Acquisition reporting. So a lot of this stuff, of all these, I think this one's the easiest to just go down and check off. Subject preparation. Was there mock scanning? Were there special accommodations? So for example, if you were scanning kids, the MRI system description, what kind of scanner are you using? What kind of coil? Hardware modifications, software version, things like that. And one thing the paper recommends is not using scanner-specific terminology. So use general terminology so that if you're a GE user, what you describe should be easy to understand by somebody using a Skyra. MRI acquisition general, the pulse sequence type, imaging type, the typical essential sequence parameters, your echo time, your TR, your flip angle, the number of volumes. So almost all of these are required, not the mock scanning, but the rest. This seems like a lot, but I often see this, it takes like 2-3 sentences if you do it well. And then all these other things, inversion time, echo time difference, blah, 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 all these others. Oh, if you run diffusion MRI, there are more specifications. The phase encoding direction, parallel imaging method and parameters, multiband parameters. Of course, if you're not using multiband, don't need that. Fat suppression, other essential imaging parameters, slice order and timing. Acquisition orientation, slice position procedure. All right. The brain coverage, the scanner side processing. Oh yeah, preset processing. Sometimes motion correction is done, prospective motion correction is done in the scanner and things like that. So that needs to be specified. And distortion correction. Other non-standard procedures, T1 stabilization, diffusion MRI, gradient table, preliminary quality control, motion monitoring, and incidental findings. Right, so what did you do? You had an incidental finding. So those aren't, fewer of these are required. All right, now back to the part I know more about. I don't actually run the scanner, so. Pre-processing reporting, what software did you use? Include your version number and revision number. So don't just say I used SPM12, say I used SPM12, revision number, blah, blah, blah. Don't just say I used, FSL, what are they up to, 6? But then they'll have a specific number for that version of FEAT that you used if you're using FEAT to analyze the data. It's really important. Include your software citation, and one of the reasons that could be important is sometimes when the software comes out with a brand new release, there are a lot of bugs that have to get worked out. It's unavoidable. And sometimes you may have run a whole analysis with a bug in it and you didn't know because it ran just fine. But if somebody is looking back at your analysis later and they see a big difference, they could say, oh, well, yours was using this kind of weird, there's a weird thing going on with the slice timing correction then or something like that. Anyhow, so that's really informative. T1 stabilization, how much of the data did you dump at the beginning of your scan, if the scanner didn't already do it. Brain extraction, how did you do it? Did you have to do any manual editing? Segmentation, whether or not you did it, how it was done. You may not need to run segmentation necessarily. Slice timing correction, if it was performed, how you did it, what your reference slice was, interpolation used. Motion correction, again, be clear about what software you use to do this. So this is talking about motion during a run. And you want to include all these details that are listed here. Function to structure or intra-subject co-registration. So within subject registration, again, what did you use? Well, this is interesting. They say to report the cost function. I very infrequently see that reported. So hopefully you know the defaults if you're just using defaults. Distortion correction, whether or not that was used. Inter-subject registration. So there are a lot of things to report here. Software and method. Did you use nonlinear registration? I'll let you go through all these. There are tons of options here just because there are just so many different ways to do inter-subject registration. So just be very clear about what you did. Yeah. Intensity correction, intensity normalization. So these are, I wouldn't necessarily say these are things you have to do. They're just things you have to report if you did them. So I have worked in labs that don't do slice timing correction. This is saying if you did do it, report it. Okay. Artifact and structured noise removal. This is so important in resting state data. I can't even stress how important it is to do a really thorough job, both removing artifact from your resting state data, and then you want to report it because, for example, personally, if I'm given a resting state paper to review and I skim through and I see that they haven't done, all they've done is put the motion parameters, the 6 motion parameters in their model to model out motion, it immediately goes on my reject pile because they need to completely reanalyze their data. So you don't want to misreport it. If you did all the work, you want to report it. Otherwise, you might go on somebody else's reject pile. So you can go through what you use to do that. Be very descriptive. If you use volume censoring, explain the criteria you use. So this is like the scrubbing approaches. So for example, from the Power papers out of WashU. Resting state fMRI feature, if you boil the data down to these metrics, ALF and FALF, blah, blah, explain how you did it. Spatial smoothing, you need to explain how you did it, what software you used. Different software do it very differently, and how much you smooth the data. And different quality control reports. I think this is really important. You need to say, after each step, what were the quality control steps that you ran? One thing, I mean, why wouldn't you? It makes you look like such a thorough researcher, for one. And you should be doing quality control. I realize what a headache it is. I personally haven't analyzed an fMRI data set from start to finish in a while, and I just did a few weeks ago. And I was like, wow, I can't believe all these things I make people do. Of course, they usually have RAs. Anyway, I realize time consuming, but so worth it. I've found at least a handful of really crappy subjects that would have just ruined my analysis otherwise. Okay, statistical modeling and inference. So I've talked a lot about that in the videos here. If you ran mass univariate analysis, that is basically all I've talked about. That's voxel-wise analyses. What's your dependent variable that was being modeled? What's the spatial region being modeled? If it's not full brain, explain what it is and how that region was defined. Your independent variables, there's a lot here. You definitely, well, just a tip, you want to model everything in your data that you can, and then you want to describe it all really clearly. I find something that you want to take a special care in describing is if you have parametrically modulated regressors. Be careful how you describe those and be clear. And I think they're kind of cumbersome to interpret, so the more clearly you can put that in the paper, the better. If you had nuisance regressors, explain that. If you're looking at group level, if you're looking at age, and you have two groups, did you model an age group interaction? Make that really clear. If you didn't, if you just added a single age regressor, make that clear. Things like that. The model type, there's mass univariate, there's multivariate. That would be if you ran an ICA, and then they have other suggested terms that you can use to go with your model analysis. So if you ran a searchlight analysis, you could call it local multivariate. Model settings, the essential details of the model for mass univariate first level, these would include your drift model, your autocorrelation model, and all that. So I've talked about these for our different software packages in different videos. If you used fixed effects, random effects, did you use Flame 1, did you use SPM's mix effects? There are all these options, so you want to be clear about which one you used. Don't just say I ran 3 levels of analysis. Each level uses a different analysis strategy, and you need to be specific. Inference contrast effects. So make sure your contrasts are really clearly defined. I sometimes find when I'm trying to describe a contrast in words, you have to use words that make it most interpretable. Just make sure those words can be translated back into your contrasts of 1s and -1s and 0s or whatnot, so that people have a really clear understanding. Inference, the search region. Was it whole brain or small volume? You have to describe that. A huge pet peeve of mine is when people show an image in their report and they applied small volume correction and it didn't tell you. It's like, wow, the activation's really focused on the amygdala. It's like, oh, it's because they used amygdala small volume correction. Anyway, that's fine. You just have to report it. Inference statistic types, just talked a lot about this. Was it voxel-wise? So for example, peak-wise and SPM. Cluster-wise, did you use cluster size? Did you use cluster mass? Did you use the threshold-free cluster enhancement? You want to be specific. The p-value computation that was used, did you use permutations? Multiple testing correction, was it based on family-wise error, false discovery rate, or none? And these are just the different ways of family-wise error and false discovery correction. Functional connectivity, confound adjustment. I already talked about this a little bit when I said with resting state data, you want to be clear about what you did. And I'm assuming here they say functional connectivity. Technically, you could do that with task data too. I'm assuming this is resting state, but perhaps it does not matter. If you used a multivariate method, such as ICA, what algorithm did you use, how the components sorted, etc. Dependent variable definition. So if you have seed-based analyses, how was the seed defined? Why did you choose that seed? For region-based analyses, how many ROIs did you report? How were they defined? So on and so forth. Functional connectivity measure model. So report the measure of dependence. Did you use a Pearson correlation, a partial correlation, mutual information? What did you use? If it was a correlation and you Fisher Z transformed it, you need to say that. What you use to estimate partial correlation, there are tons of ways of doing that. The regression model used to remove confounding effects. And then for effective connectivity, you want to report the model you use, the algorithm used to fit the model, and per subject model, method used to generalize inferences to population. Right. And itemized models considered. So most effective connectivity models, so for example, DCM, it's just a competing models situation. So you have to put the models, the competing models, list them. Graph analysis, this is when you have a bunch of nodes, say 100, you compute, say, Pearson correlations between them, and then you say, okay, a node is connected to another node if the correlation is bigger than 0.6. So, and then you come up with these different graph theoretical measures. So you want to specify how you made that what do they call it? Adjacency matrix. Is it a weighted graph analysis, a binarized graph analysis? How did you compute your graph summaries? MVPA analyses. What were your independent variables? So you want to specify the variable type. Was it discrete or continuous? The class proportions in a classification setting. So especially in classification analyses, if one group is a lot bigger than another, maybe this is just me not knowing that there is a magic bullet out there. I find those are really difficult models to deal with. But anyway, it's good to report that if you have imbalances, to report it, and you have to explain what you did about that imbalance, because the model tends to cheat in that case. Not cheat, but it classifies everything as being from one group. Features extracted from the data. How was this done? The learning method used, and the training procedure. So that would be the how did you choose? Yeah, this is a big pet peeve of mine, the hyperparameter setting. So for example, with support vector machines, depending on the kernel you're using, there are typically 1 or 2 parameters that need to be set. I find a lot of people just go with the defaults. You should probably go through an actual selection procedure, and if you do, you need to explain how you did it. Also, if you ran cross-validation, how was that done? Was it leave one run out, leave one subject out, etc.? Or, split half or whatever. So many different ways of doing cross-validation. Evaluation criteria. Right, how did you get your accuracy score? How did you determine whether or not it was significant? And feature importance. Oh, if you are pulling out features and claiming them to be informative or important, how did you determine that? All right, results reporting. Massive univariate analysis, the effects tested, the table of coordinates. There are tons of ideas here that you should follow for making those tables and making them as clear as possible. Thresholded maps. Right, you basically want to have a descriptive caption. You want to again repeat the thresholding strategy used. Was it a cluster-based thresholding, cluster-forming threshold of 2.3 with a cluster size threshold p less than 0.05? So you want to repeat that information. It will be in the body of the text, but you also want it in your figure caption. If you ran an ROI analysis, where did the ROI come from? Make sure it's not biased. And spatial features, size of the analysis, volume in voxels, and the spatial smoothness of your noise. So the full width half maximum, for example, the Russell count should be reported if you're using random field theory. Okay, if you ran functional connectivity, if it was ICA, report these things. If you ran a graph analysis, what was the null hypothesis tested? If you ran MVPA, evaluation metrics, these are things that you always want to report. Your accuracy, group sizes are unequal, report that, and then these different metrics: precision, recall, false positive rate, F1, ROC curves, so on and so forth. Evaluation metrics for a continuous response. There's this prediction R-squared metric. Representational similarity analyses, or RSA analyses. There's a Kendall's tau statistic for each candidate model considered. And significance. If you can, you want to do a formal test to get a p-value to take into account the noise in your data. All right, data sharing. Reporting a data sharing resource. So you want to consider the material that will be shared, URL and access information. So you want that to be stable. You want it to be something that's going to go away in a year, and you want to consider the cost. Ethics compliance, you want to do this again before you collect your data. Documentation, data format, what format are you going to store the data in? The ontologies, That's just the data organization structure, visualization, de-identification, how will the data be de-identified, the provenance and history, so this is just a record of what has been done to the data. Interoperability, can the data be used across multiple database environments? Querying, can somebody query the database to, say, find subjects with a certain IQ? And versioning, check the version of the downloaded data that they have and compare it to the current version in a later time. So these are things to consider. I actually highly recommend reading the data sharing section. I feel like there are more details there. Things like planning ahead of time and other considerations. And then they also talk a lot about you don't want to create your own database. You're much better off using ones that are already there. And it shouldn't be a decision that's made hastily. It really depends on who you're working with, your institution, your resources. So I know we used, oh boy, let me get the wrong one. We used XNet at UT because it worked well for our purposes. And currently the people I work with here I believe they're using Coins. And for various reasons. They're both, I'm sure, perfectly fine databases, but one worked better than the other at each institution. All right, so those are things you want to consider. And obviously, you may not be able to afford having a database for your data at your institution. So in that case, just use standardized construction of your directories, basically, in your workflow. And you can still do things like this provenance and history. You can keep track of what you've done. Just keep it as clear as you can. And they have examples of different ways of structuring your data. So I forget what it was, but one is to follow the OpenFMRI. It's based on the structure in the OpenFMRI database. And that's what I'm familiar with because I used to work with Russ Poldrack. And yeah, I find that structure is really great. I can write a script and anybody who uses that structure can just plug in their subject numbers and use my scripts. And that's actually how a lot of our stuff was done. Anyway, big fan of that. Okay, last, reproducibility. Tools used, infrastructure. So a lot of this is kind of repeating from above. Workflow, use a workflow system like NiPipe or the Lonnie pipeline. The provenance trace, again, what is this information? What was done at each step along the way? Literate program implementing results. So providing a URL linking to relevant resources. For example, an IPython notebook. There's this other thing for R, if you use R, it used to be called SWeave and now it's called Knitr, and it's amazing because you can just type your code and it gets formatted into a LaTeX document or a URL, HTML file, sorry. And it's great because it has your code and then the output of the code, you can insert text and tables and things like that. And I like using it if I'm writing a tutorial for somebody. So I did it before when I was talking about a double dipping issue. If somebody doesn't want to run the code, they don't have to. The output's there. If they do want to run the code, they can. And there's just a complete record of what I've done. They can see the output. Yeah, big fan of that. I really like that. Citation, you want to have data and workflow. And you want permanent identifiers if possible. And again, not all of these are required. But yeah, so that's it. That was long. But again, I wanted people to see this. Go through this on your own. If there was something where you're like, I wish there was more there. Like going through it right now, for me, I feel like the database information didn't quite make it. All of it hasn't made it really into this table that was in the text. So things like that. So I might submit some recommendations based on that. Yep, so again, you can leave comments right here on YouTube. You can leave comments on the Facebook group. You can tweet them at me at MomBrainStats or on the Tumblr, and I'll make sure they get there. The table's not the only thing. Again, there's a whole white paper that goes over it as well. So that's it. Well, I'm just going to say thanks and have a great day, and I look forward to hearing your feedback.